Hi everybody, it's Mr. Holding here, and this video is a follow-up from my one on Punnet squares. This one is looking at probably some more complex examples. So what we're going to do today is look at this one here where we've got essentially an unknown mother and father. Okay, we want to find out what are the chances of the unknown mother and father having certain genotypes. Okay, and we're going to look at eye color. So capital B is dominant for something other than blue, and the recessive is blue. So we'll just look at that one. So we don't know mum or dad, but what we do have here is we've got mum's father, so the grandfather of the unknown down the bottom here, which we haven't done yet, and the grandmother. So we know that the grandfather is big B, little b, which means they won't have blue eyes, but they carry the gene, they're a carrier, and the mother is the same. So we can then quickly go and do the cross here, and we end up with a situation like that. Okay. We can then go and work out the percentages. So big B, it's 1/4, or is 25%. 2/4 equals 50%, or 1/2. And the recessive is 1/4, which is 25% again. So this is the chance of the mother. Okay, so we don't know what mum is, but 25% chance that she is homozygous dominant. There's a 2 or 1/2, 50% chance that she is heterozygous dominant, and there's a 25% chance that she is homozygous recessive. Let's go look at dad. So we quickly go and do the simple Punnet squares, and look at that. Dad is 4 out of 4 heterozygous dominant. So that's all he can be. So we know dad now, definitely. He is definitely big B, little b. Okay, now we want to combine these two into a larger one. So we can start off by going, let's put the father at the top. And he is this one here. So he is big B, little b. And that's all he can be. So it's simple as that. All right, so we can put this down here. But now we have to work out mum. Okay, so what is mum? Mum is 25% chance big B, 50% chance big B, little b, or a 25% chance little b. Now, if we look here, if we look at she is twice as likely to be this one than she is the other two. Okay, so we can see that by the fact that it's these two are 25%, this is 50%, or this is 2 out of 4, and these two are 1 out of 4. So we have to represent these two genes these combination twice as many. So if we start from the top, and I just tend to follow down whichever way I've got it written. So I'm going to put this one once. So I put big B, big B. Okay, so these two here are these ones here. Now these, remember, we have to represent them twice. So big B, little b once, big B, little b twice. Okay, so these two here, is represented twice as much as that one. Okay, and then finally I've got my homozygous recessive, and again this is represented twice. And then all I do is go and fill them in. So I've gone and finished my table off, and I've gone and quickly input these so you don't have to watch me writing them. So what we've done now is it's a more complex version of this, but the principle's the same. All I have to do is cross them. So big B, little b, big B down, big B across here, but it's a little b. Okay, now all I do is then go and count them up and write down, first of all, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So all of these will be out of 16. Okay, so go count them up and put them. So I've gone and done that, and what I found was there was, out of all of this, 4 of them were homozygous dominant. So 4 out of 16 is the same as 1 over 4, which is 25% chance. The next one, heterozygous dominant, there was 8 of those, which is 1 over 2, or 50%. And finally, I have homozygous recessive, which is 4/16, which is a quarter or 25%. So what we're saying is now that we know that the unknown child has a 25% chance of being homozygous dominant, has a 50% chance of being heterozygous dominant, and has a 25% chance of being homozygous recessive. And we're able to do that using its grandparents' genotypes. Okay, so I hope you found this helpful. This is something you're going to have to do in your assignment. So have a watch through this a couple more times if you have any problems, or come and see me if you need any help. Hope you found this useful.